So what I'd like to talk to you about today is arrays and how we can use them to make our processing more efficient and to use less code. So the way we've been doing things up until now is we've been using what are called scalar or discrete variables. Every variable in your program is different. So if I wanted to write a program that kept track of my business's sales for every day of the week, this is how I would do it. I would write 7 different variables. When I went to input them, I'd have to do this over and over and over again. So it's pretty time consuming. And think about it, if I was doing it for 365 days of the year instead of 7 days of the week, that would be horrible. So what we can do is we can use something called an array. And arrays are used when you have a series of variables that are similar, going to be used the same way. Like these sales variables are all doubles. We're going to use them the same way. We're probably going to process them one after another in order like we did here. First the Sunday, then the Monday, then the Tuesday. So arrays are what's called a data structure. It's a different way to declare my data, and it's really a shortcut. So instead of having individual variables, I would do something like this. I would make an array. So this is my array. Like every other variable, it has a data type. This is going to be a double. It has a name. And then in the square braces, I have to say how many elements there are in the array. Well, I'm going to have 7. I want to have 7 of these different variables. And what I'm doing here is a type of structured programming method. I have a constant called numSales, and I'm using that in place of the 7. I could use 7 here. That's fine. But you'll see as we go down through, I use this in a lot of different places. The 7 comes up, and what if I decide to close my business on Sunday and Monday? I don't want to change it to 5. I would have to change it a lot of different places in the program. This gives me the ability to change it once, and then it will ripple down through the rest of the program. When I change this to 5, it'll be 5 here, 5 every place else. So it's a good habit to get into. This is my initialization. This is how I would initialize it to 0, and really I should technically do 0.0. This is what's called a short initialization. If you'll remember, if we don't initialize a variable in the Windows environment, we don't know what the initial value is. So here I declared a variable total sales without saying it equals 0. I don't know what its value is going to be. You would assume it's 0, but it probably isn't. It's going to be whatever is left in that place of memory from the last execution of a program. So this is similar. I could do each one individually, do this 7 times, but they were nice enough when they made C++ to do this thing called a short initialization. If I initialize the first variable to something, anything, all the rest will be initialized to 0. So this effectively is initializing every element in the array to 0. So it's doing the same thing as all these are here. So this is how I declare my array. We use for loops to process arrays. So if you're going to do something with your array where you're stepping through every value, like I'm going to process the first element, and the second, and the third, and the fourth, and the fifth, I can use a for loop or the counted loop. When I access an element in the array, I have to say which element. If I just try and access the name, I'm not going to get anything. I'm actually there at that point. The name of the array by itself is actually a memory address. So can't do that. I have to tell it which sales I want. My array elements are numbered 0 through however many there are in the array. So here I have 7 elements. The subscripts they're numbered 0, 1, 2, 3, 4, 5, 6. So we start counting at 0 instead of at 1. So when I do my for loop, it's always going to be the same thing. I need a counter or a subscript variable. I'm using X. I'm going to do it while it's less than the number of elements in the array, and I'm going to add to it every time. So as we go through this loop, the first time the loop happens, it'll prompt me to enter the sales amount, and that will be entered into sales 0, the first element in the array. We'll add 1 to X, and the next time around it will go into sales 1, the second element in the array, and it will continue until we've gone all the way through the array. So this for loop is what we use when we're going to step through every element of the array and process them in order assembly line fashion. This loop is the same idea, but here I'm outputting every element in the array. Here, I'm doing something similar. I'm finding the total, but I'm going through every element in the array. I'm adding the first element in the array, element 0, to total sales. Then the second, element 1, to total sales. And the third, and so on and so on. So this for loop thing, this whole thing is pretty much of a formula. It's what happens in the middle that's going to change depending on what I want to do. When I want to reference an element of the array, I must use a subscript with it so that C++ knows which element of the array it needs to process. We also have some cute little extras down here. This bit of code will find the lowest number in my array. I need a holding variable called lowest number, or whatever you want to call it. I'm going to initialize it to the first element of the array. And then I'm going to step through this array comparing the array element to the lowest number. If it finds an element in the array that's lower than the lowest number, it will replace lowest number with the new low number. And the highest one works pretty much the same way, but you're doing a greater than. Okay, so that's the first part, and I will send you the code to that. Another thing that we can do here is use something that are called parallel arrays. So I want to have the days of names. So let me go back and run that program. So when I run this program, you'll see it's going through, this is the first loop. So it's asking me, I'm doing this loop here, it's asking me to enter the sales amount, so I'm going to put that in. And it should go through 7 times. Okay. So I repeated this loop 7 times. Entered, this one into element 0, one into 1, 2, 3, 4, 5, 6. So all 7 elements were filled. And then this one just displayed the elements in the array in order. In this one, I found the total sales by just adding to the total. I found the average by dividing the total by the num sales, the number of elements in the array. And here is where I got my lowest number and my highest number. Now to add to this, I would like to see enter the sales amount for Sunday, enter the sales amount for Monday, Tuesday, Wednesday, Thursday. So I'm going to use something called a parallel array to do that. And we'll also introduce you to the string variable. Strings are words. We've been using strings all along in our prompts. Okay, that's a string, something in the double quotes. There is no string data type in C++, so we have to include the string header file to do this. And then I'm making an array of type string. I'm going to call it day names. It's num sales long, exactly like the other one. And here I'm initializing it with the days of the week. So it's string data. Each individual element is separated by a comma. So this is element 0, element 1, element 2, element 3, element 4, element 5, and 6. So it goes parallel to this one. So element 0 in sales would hold the sales amount for Sunday. Element 1 in sales would hold the sales amount for Monday. And then Tuesday, etc., etc. So here, in this loop, when I'm asking for the sales amount for the day, I'm using the same variable for the subscript because they're kind of going along lockstep. 0 is Sunday, 0 is Sunday. So oftentimes you have arrays that are parallel to each other. So now we're getting that text. So that's my parallel array. The last thing I want to show you with this type of array is how to create a function and pass the array to the function. So here is basically what I was doing before to input the data. Exact same thing. But now I have moved it down to an array. I've given the array a name, and I'm passing two things into it. I'm creating an array called double array, and it's going to be num elements long. When the array is called, it's going to pass sales, the name of the array, to here. The name of the array by itself is not data, it is a pointer to memory. So it's really a memory address. It's passing from main to here the memory address of sales. So this is what we're doing here, is really this passing by reference that they talked about in chapter 10. In this function, I am actually changing what's in the sales array. I have two names for the exact same place in memory. So in main, I'm referring to it as sales. Down here, I'm referring to it as double array, but they both have the exact same memory locations because I'm passing the memory location to here, and it is making it the appropriate size. I don't have a size in here based upon how many elements are in this array. So different names, but they are actually accessing the same area of memory. And that's why I don't have to return anything here. When I enter data into this array, it's also going into here because it's the exact same location. Different names for the exact same thing.